Calculus 8.5, area between two curves expressed as a function of y. And I decided to do this graph in Desmo so that you could really see what I'm talking about here. What it means to be expressed as a function of y is this. Instead of having a y equals or an f of x equals function, you will have an x equals, and the function will be in terms of y. In other words, x equals like 2y, or x equals y squared plus 2y, something like that. Instead of it being solved for y, it's going to be solved for x. And we can still find the area between the two curves, but we have to think about it backwards. Remember, when our equations were solved for y, we used our a and b as vertical lines, okay? But when we're talking about curves being expressed as functions of y, in other words, where x equals the function, we have to think in terms of looking at this thing sideways. And if you think about the area between two curves when it's expressed as functions of x instead of y, didn't we say it was the top function minus the bottom function to get the area between? Well, if you're thinking about it that way, wouldn't the top function, when you look at this thing sideways, be the green function here? It's the one on top. It's got the higher x values. Okay, and wouldn't the bottom function be this one right here? If you think about it, looking at it sideways like that, the top function is the one with the highest positive values. The bottom function is the one with the lower x values. Okay, so if we're looking to find the area between these two curves, we're going to be finding this shaded region right here. So we're finding the area between those two curves. I want to just quickly show you what these equations were. So I'm going to get rid of this, the shading. You know now that that's what we're shading. And so I'm going to get rid of the shading so we can really look at these functions a little bit closer. So these are the two functions that I have graphed here. The x equals 3 minus y squared. If you remember your work with conics, when you did sideways parabolas, I call these sideways parabolas, it was an x equal parabola. So 3 minus y squared, and you could just plug some ordered pairs in to check, and that's going to be this green parabola right here. And then the x equals y plus 1, again, you could plug some ordered pairs in for x and y and come up with this line. But what we're looking for is the area between these two curves. And since these were in terms of x equals, we have to look at this thing sideways. So we're looking in this direction where the green function is what I would consider my top function, and my red line is what I would consider my bottom function. And remember, when we were doing functions expressed in terms of x, remember our boundaries went from a to b, and a and b were left to right. Now, since we're looking at this in terms of y, our boundaries are going to be up and down. Instead of A and B being this direction, they're now going to be horizontal, okay? Instead of vertical, they're going to be horizontal. So what we need to do is figure out what are the y values where these two things intersect. Remember, when we were expressing it in terms of x, we looked for the x values where those two things intersected. But if it's in terms of y, we're more concerned about where the y values are that these are intersecting. We need these ordered pairs, this one right here and this one right here. Now, those ordered pairs, if I look at this, that's y value of 1, so it's at 2, 1. This ordered pair is at -1, -2. So my boundary is going from my y values this time, remember, -2 to 1. -2 to 1, because those are the y values where these things intersect. So my integral goes from -2 to 1. And then remember, my top function is the green function. So my top function is going to be the 3 minus y squared. My bottom function is going to be this y plus 1. And to find the area between the two curves, remember, I subtract these two functions from each other. So this is my entire setup. My integral goes from -2 to 1. My top function, 3 minus y squared, minus my bottom function, y plus 1. Remember, top is furthest to the right, bottom furthest left. This will give us the area between the two curves. So if I just integrate that, and I didn't mention this before, but this is a dy because y is our variable of integration this time, because it's in terms of y. That's why we have y instead of x here. That was our variable. So first thing I did was subtract these two from each other. So that gives me 3 minus 1 is 2. Then I've got negative y squared and then minus y. I have to distribute that minus sign. And then I integrated to get 2y minus y cubed over 3 minus y squared over 2. Now I need to plug in. I'm going to do that down here. So I would plug the top number in first and then the bottom number. And that will give me 9/2. Okay, so here's the next one. Find the area of the region bound by the two curves x equals 4 minus y squared and x equals y minus 2. And sometimes you might be asking yourself, well, wouldn't this be easier to just solve for y and then go from there? Not necessarily, because if you look at this function, if you were trying to go from left to right, finding the area under the curve, you'd get the same answer, but it becomes more complicated because look at the functions that are on top. This function is on top here, so from, I guess that would be -5 to 0, but then this function is on top of itself on this side. So really, it is easier to just look at this thing sideways and go left to right instead of up and down, because this causes some more significant math to happen, and it just makes it more difficult. So if you just move your thinking to thinking boundaries going from bottom to top instead of left to right, it's easy to do it this way. So let's look at this. We've got the top function is the green function again. The bottom function is the line here. So the top, it would be this one minus this one. It's going to be our integration of the 4 minus y squared minus y minus 2. So I'm going to set that up first. And then I need to understand my boundaries. And remember, my boundaries go from top to bottom now. My top y value here looks like that's at 2 for the top, and the bottom here looks like that's at -3. And so this is the integration that I'm going to do. I'm going to combine them first. When I subtract the two functions, I end up with 4 minus -2 is 6, minus y squared minus y, and then I integrate. Okay, so for the integration, I get 6y minus y cubed over 3 minus y squared over 2, going from -3 to 2. Then I plug in the 2. That gives me 12 minus 8/3 minus 2. Then I plug in the -3. That gives me -18 minus -9, because that's -27 over 3, which is +9, plus 9. And then -3 squared is 9 over 2, so that'll be a minus 9/2. And then I just plug that in my calculator to get 125 over 6. So the next thing I want to do is show you a delta math problem to make sure you understand what they're asking us to do there. Okay, so in delta math, what they're going to want us to do is do this both ways, in terms of x and in terms of y. So this kind of combines our 8-4 and our 8-5, yesterday's lesson and today's. So if we're doing this thing in terms of our x's being our boundaries, look at this. Our x boundaries are at 0 and at 9. Okay, so the x boundaries go from 0 to 9. And our top function would be 1 minus this bottom function. So in here I would have a 1 minus, and the bottom function was the square root of x minus 2. So I'm going to put the square root of x minus 2. And you have to be real careful, make sure you're not putting the minus 2 underneath the radical. Okay, so there's my first one. That's a straightforward in terms of x problem. Now we have to think about, what about the ones in terms of y? Okay, so in terms of y, our top function would be this function right here, and our bottom function would be this function right here. So it'll be this function minus 0, because that's x equals 0 line. Okay, so our boundaries, our y values, where these things intersect, go from -2 to 1. Okay, so this is -2 to 1. And then here, my top, this is the top function, but the problem with that is it has to be in terms of y. We have to solve this thing and get x by itself. All right, so that is f of x equals the square root of x minus 2. I'm going to go back and into notebook and do that in there. So f of x equals square root of x minus 2. F of x equaled the square root of x minus 2. I need to solve this for x, get x by itself. So, well, we know f of x equals y. That's the same thing as y. And so if we're going to get x by itself, that's going to be y plus 2 equals the square root of x. And to get rid of the square root, we square both sides. So that gives us the function y plus 2 squared equals x. So we have solved that for x. So this has to be in terms of y in order for the boundaries going from y to y to work. It has to be in terms of y. And this right here has to be y plus 2 squared. And that should be everything we need. All right, so we're going to submit. So notice this one, when our boundaries are from x to x, these have to be in terms of x. For this one, when our boundaries are from y to y, this has to be in terms of y. We have to rewrite the equation that was in terms of x and make it in terms of y. Okay? So they're making you really think about what you're putting in these. Okay, let's submit. And we got it right. All right, so that's it. Hopefully that's enough information to move you forward and to get into some more area under the curves or area between the curves. And we're going to pretty quickly move into volume. That's the next step.